Great day everyone, my name is Brent B. Antonio from ECE1GH. In this video, we're going to find the derivative of three different transcendental functions. So for our first problem, we have an implicit trigonometric function wherein cosine x squared is equals to y plus sine y. So just like any other implicit functions, we are going to first find the derivative of each sides. So let's take a first look at the left part, which is the cosine x squared. So how are we going to find the derivative of cosine x squared? As we all know, the derivative of cosine u is equals to negative sine u derivative of u. In our case here, our u is equals to x squared. So we can write the derivative of cosine x squared as negative sine x squared times the derivative of x squared here is 2x. So times 2x equals to the derivative of y is of course y prime, and in terms of finding the derivative of sine, we know that the derivative of sine u is equals to cosine u times derivative of u, wherein in our case our u here is equals to y. So we can say that the derivative of sine y is equals to positive cosine y, the derivative of y is y prime. So now we have this function. After finding the first derivative of an implicit function, we are now going to transfer all of the terms that have y prime in them to the left part and all of the terms that don't have y prime in them to the right part. So because y prime here is positive, we will going to write this as negative y prime minus cosine y prime equals to, because this is negative here, this will going to be positive, sine x squared times 2x. Now we're going to factor out the y prime in the left part. So y prime times quantity of negative 1. Why negative 1? Because negative y prime divided by y prime is of course negative 1. So negative 1 minus cosine y is equals to sine x squared times 2x. So we are going to find, or we are going to cancel out the negative 1 minus cosine y in the left part by dividing both sides to negative 1 minus cosine y. So negative 1 minus cosine y, and then the right part also negative 1 minus cosine y. So this will be cancelled, leaving us with our final answer, which is y prime is equals to sine x squared times 2x all over negative 1 minus cosine y. So this is the final answer for this problem. Now let's go to our second function, which is an inverse trigonometric function wherein s is equals to arc sine square root of x over x plus x squared. If we analyze this function, we can say that we can apply the sum rule, wherein we can find the derivative of each terms independently from each other. So the derivative of s is s prime equals to, if we take a look at the first term, the arc sine square root of x all over x, we can say that we can apply the quotient rule, which is the low times derivative of high minus high times derivative of low over low squared. Of course, the low that we are talking about is the denominator, and the high that we are talking about is the numerator. So according to this rule, we're just going to write the low, copy the low, which is x times derivative of high. So in terms of finding the derivative of arc sine, we know that arc sine u is equals to derivative of u all over square root of 1 minus u squared, and in our case, our u is equals to square root of x. So according to this rule, we must first find the derivative of u. So the derivative of square root of x is 1 over 2 square root of x all over square root of 1 minus u squared. Our u is negative. Our u here is square root of x. So square root of x squared. So minus high. Just copy the arc sine. The arc sine square root of x times derivative of low. The derivative of x is simply 1 all over low squared. Our low here is the x, so it will be x squared plus the derivative of x squared is 2x. So now we're going to simplify this function. We're going to distribute the x in here, leaving us with x all over quantity of 2 square root of x times quantity of square root of 1 minus x minus the arc sine square root of x all over x squared plus 2x. So this is now our final answer. Let's now proceed for our last problem for this video. For our last function, we have here an implicit hyperbolic trigonometric function wherein x hyperbolic sine y is equals to hyperbolic cosine x. And as we all know, in solving the derivative of implicit functions, the first thing that we have to do is to find the derivatives of both sides. So let's first focus on the left side, wherein x hyperbolic sine y. If we analyze it carefully, we can know that we can apply the product rule, wherein u derivative of b plus v derivative of u. Our u here is the x, and our v here is the hyperbolic sine y. So just copy the u, and the derivative of hyperbolic sine y, we all know that the derivative of hyperbolic sine u is equals to hyperbolic cosine u derivative of u. And in this term, our u is equals to y. So just copy the hyperbolic cosine y and the derivative of y is y prime plus v. So just copy the v, which is the hyperbolic sine y, times derivative of u is 1. So now we're finished in the left side. Let's now go to the right side, wherein the hyperbolic cosine x is needed to be derived. So in terms of finding the derivative of hyperbolic cosine, we know that the derivative of hyperbolic cosine u is equals to hyperbolic sine u, derivative of u, which is in our case, the u is x. So just copy the hyperbolic sine u. So hyperbolic sine x times derivative of x is 1. So now, after getting the derivatives of both sides, we are now going to transfer all of the terms that have y prime in them to the left part, and all of the terms that don't have y prime in them to the right part. And because the x hyperbolic cosine y prime have y prime in it, we're going to write it in the left part. And because the hyperbolic sine y don't have y prime in it, we're going to write it or transpose it to the right part, leaving us with x hyperbolic cosine y prime is equals to hyperbolic sine x minus hyperbolic sine y. Now we're going to factor out the y prime in the left part, leaving us with y prime times quantity of x hyperbolic cosine y equals to hyperbolic sine x minus hyperbolic sine y. We're now going to cancel the x hyperbolic cosine y in the left part by dividing both sides to x hyperbolic cosine y. So just divide both sides to x hyperbolic cosine y. This will be cancelled, leaving us with our final answer, which is y prime is equals to hyperbolic sine x minus hyperbolic sine y all over x hyperbolic cosine y. So this is our final answer for our final function. Thank you for watching. I hope that I was able to teach you how to find the derivatives of different transcendental functions. Laus Deo.